sorry, I'm back. Alright, so this is now part 3 of the notes on undefined terms and collinear and coplanar. I had a little barking issue with my dog, but I'm back. Alright, so we're working on the we do example, which is all about a pool table with 3 balls. Alright, so what they tell us is that one of them is not on the table. I'm going to underline that part. That's really important. Okay? One of them is not on the table, and we want to know which one. Okay? They give us the equation for the pool table. So let's highlight that. Okay? X plus 2y plus 2z equals 5. Now we know ball 1 is this, and ball 2 is this, and then ball 3 is right here. So the first question is, which student had the right approach? So student 1 thinks that we should substitute each coordinate point into the equation, and the other student thinks we should match the point to the numbers in front of the parts of the equation. Alright, now if they take a moment to think, which one do you think did this correctly? Now I hope you picked student number 1, because student number 2, that is not an accurate way. Alright, it doesn't matter whether these numbers actually match these ones, right? Because that's not how you figure out the numbers. What you want to do is you want to substitute. Alright, now this problem is probably going to seem a lot easier than the one above, because in this one they already give you the equation. So they already get all of this work right here done for you. So you just have to do step 2. Now a little tip, these points might look weird. Okay, the reason they look weird is because they are 3D, right? They're 3-dimensional, which means that in 3D a point can have an X, a Y, and it will have a Z. Okay, so it has 3 numbers, right? If you were to graph this, this is what the graph would look like, right? It has an X line, a Y, and then it also has a Z. And what those 3 lines represent is length, width, and then Z is height. So what you're used to is this part. You're used to the floor, right? This would be the coordinate plane. So what they've done is they just take the coordinate plane and they sort of raised it up so that it would have this height factor. Okay? So this is why there's 3 numbers, so do not fear. Alright? But they give us the equation already, right? The equation was this. So all we have to do is test each of the balls. So let's try ball number 1 first. Now ball number 1 was 1, 1, 1. So this is X, Y, and Z. Okay? So we know our equation is this. So we have 1 plus 2 times 1 plus 2 times 1 equals 5. So I just plugged in the 1s each of these spots. Okay? We get 1 plus 2 equals 5. 1 plus 2 plus 2 is, in fact, 5. Now you can see what happened. This is different than what happened over here, right? Here we got 5 equals 5. This worked. Check. That means this one is coplanar. Right? Now remember, coplanar is when we are 3D. Collinear is when we are 2D and we only have 2 numbers. It's coplanar, which means that this is on the table. So this is not going to be the ball that we want, because this one is on the table. Let's try ball number 2. Okay, so let's plug it in. Ball 2 is 2, 0, 3. This is X, this is Y, and this is Z. So if we plug it in, we get 2 plus 2 times 0 plus 2 times 3 equals 5. Simplify. 2 plus 0, right, because 2 times 0 is 0, plus 6 equals 5. So that is 8 equals 5. So you can see this time they are not equal, right, which means this is not coplanar. and not on the table. So this is in fact our answer. Okay? It tells us one ball is not on the table. Well, this one didn't work. It's ball 2. Now, at this point, you don't have to check ball 3 to make sure it's on the table, but you could. So just to show you one more time, if we check ball 3, which point is 1, 2, 0, right? Label it X, Y, Z. Substitute it in. 1 plus 2 times 2 plus 2 times 0 equals 5. Simplify. 1 plus 4 plus 0 equals 5. And you get 5 equals 5. Just like ball number 1, this one works. This one is, in fact, coplanar. So just remember, this is our answer, right? Because ball 2 was not on the table. All right, for the last one, okay, this is the you do, right? Jill and Margaret live on the same street. Jill lives here, Margaret lives here, and we want to know if Joe is collinear, right? So our first clue is collinear, which means, and they do not give us an equation, so this is going to be just like the one up here, okay? So that means first I want to find slope, right? So slope, I'm going to make this, I'm going to put all my points over here because we have Jill and Margaret and Joe, right? So this one was 4, -8 to 5, and Joe was 4, 5. Now I want to use Jill and Margaret because we know they live on the same street, so that's the equation we want to find. So I'm going to label this one x1, y1, and I'm going to label Margaret x2, whoops, y2. Okay? Plug it in, we get 5 minus -8 all over 2 minus 4. This becomes plus plus, this becomes plus minus, and we get 13 over -2. This is our slope. Okay, now what I'm going to do is I'm going to plug it into my equation. I'm using Jill because she was my x1, y1. So y minus -8 equals my slope times x minus 4. Make this plus plus. Okay, so here's my equation. Right then, so now I know Jill and Margaret live on this street, right? If streets were really coordinate planes, this would be the line that represents their street. So now I'm going to test Joe and see if he lives on their street. So I'm just going to plug Joe's points in, right? X, Y. So we get 5 plus 8 equals 13 over -2 times 4 minus 4. 5 plus 8 is 13. 13 over -2 times 4 minus 4, 0. Now, anything times 0 is just 0. So look what happened. They are not equal, which means Joe is not collinear and does not live on their street. And this is my answer. So this is, again, a typical problem that you will see. And then sometimes, like this one, they'll give you the equation and you just have to substitute. This is UT1 and UT2.